Okay, today let me review a basic knowledge which we have learned in elementary school or middle school. What is a rational number and irrational number? Okay. And rational number like 1, 2, 3.4, 3.14, something like this, right? Or more, 3, 1, 4, 1, 4, 1, 4, okay, 1, 4, 1, 4, right? Let's stop. Also integer, even number, something like this. Irrational number, we know, okay, just means very simple question. Radical 2, radical 3, radical 15, right? Or E, when on the high school, you know what the E, very important, right? E, that means approximately is 1.17 something, right? And pi, something like this. Rational number just means all the number is a limited number. Okay, maybe it's a long digit or very digital. But it can repeat, although it's very, very long, right? 1.4, 1.4, 1.4, 1.4, you can find the rule, 1.4, 1.4, 1.4, 1.4, 1.4. Also, it's unlimited, but it's repeat. Irrational number, right? That means you can write, you can use a calculator to test. It's unlimited, but not repeat. You cannot find the rule what it is. We know all the rational number can be write at fraction form, m and n. All of this question you can write m and 4 rational. Okay, fraction form, but the numerator and denominator now common factor, right? Irrational number cannot be read like this form, right? If you write the form must be has some common factor. Okay, there's a basic knowledge, right? The common sense. Okay, now. Today, let me prove radical 2. How to prove a number is irrational number. Right? Like this. Let's prove this one. Okay, show that radical 2 is a irrational number. Let's improve this one. But based on this knowledge. Irrational number. How to prove this one? This question. We use this method, contradictionary method to do that. This method is very, very important, right? Contradiction method. On mathematics, and when I prove this question, we often use this kind of method to do that. Okay. How to do that? This conclusion, we use the contradiction method to do that. So we first, let me suppose this conclusion is not true. That means suppose radical 2 is not an irrational number. All the number either is rational number or irrational number. If this is not irrational number, that means then this radical 2 is a rational number. Okay. We try to deny this one. Okay, suppose this is an irrational number. That's an irrational number. That means by the definition, right? If this is a rational number, then the radical 2, okay, can be right as a fraction form. MON, right? And also MN, not common factor, where M and N has no common factor. M and N have no common factor. Okay, right now you see radical 2 can write this kind of form, right? Fraction form. We square both sides to the equation, right? Both sides to this, so which is then they get 2s m squared over n squared. Right. So we get m squared as 2n squared. Okay. Look at this right side. All the number, right? All the number. I'm sorry, here I miss one. M and N has no common factor. And as integer, and have integer. M and N have are integer, I'm sorry. It's are integers. And now let me read this again. Okay, here, because this is very, very important. Where M and N are integers. And both M and N have no common factor. Right? It's very, very important. Right? Now, we'll continue. Okay, this can write m is m squared equal to 2n squared. Okay, we know all the number times 2, right? 2 is even number. 2n squared, this one must be even number. That means m squared is even number. So, we get this result. M squared is a even number. M squared is even number. So some integer square is even number. So we know m is an even number. Right. M squared is even number. If one integer, even integer is even number, so we can m can write is like this, 2k, which k is integer. Even number, not you can write 2 times some number, integer. Okay, look at this. So here, m squared is 2n squared. M is integer, is even number. So if m is even number, so the even number must be can write expressed like this: 2 times 1 integer. Now we substitute this one to here. To here. So we get this result. And substitute here, the 2k squared is m is 2k, which is 2n squared. So we get simplify this equation. Which is 4k squared is 2n squared. Right. Simplify this equation, which is n squared is 2k squared. Back to here, same thing, right? N squared is 2 times 1 integer square. So that means right side this also even number, right? That's even number. Then we got n squared as also even number. Even number. Even number. One integer square is even number, so we know n is a even number. Okay. N is an even number. M is even number. That means, look, both M and N are even number. Right? Look at this, right? Like this form. Okay, here, m and n are both even number. What's mean? You said if this not irrational number, right? If it is rational number, that means the rational number must be can write a fraction form, right? MON, which M and N now common factor. But you prove MN above the integer, but this is an even number. Two even number must be have common factor. That means M and N have common factor. Common factor, which is contradicted with what we are supposed. All right. It's contradictory with what we suppose it. Right. So that means this one is not rational number. It's not rational number. That means this must be, no, I'm sorry, this is not irrational number, right? That means that must be rational number. So, and proof. Okay. You also can use this method to prove radical 3 is irrational number. Okay. We can learn on the high school, okay, like 12 school or K12, K11, you can write. This is very hard to prove, right? Right now you computer to prove, write down a decimal, many, you cannot find one from one position is repeat. Now rule, right? We know that 3.40. No, right? You cannot find rule. If you write this, 141594, stop here, and 141594, 141594 is repeat from here. That means rational number. But you cannot find this from one position as repeat. Formal, okay, formal decimal, formal digital, okay. Okay, thank you.